So the problem here tells us to factor. There's a number of different ways, but basically we want to figure out what do these two monomials have in common, and we can sort of divide that out. So basically we're going to have what they all have in common here, and then whatever's remaining that you can just stay here. So right away we know they're both divisible by 3. So if we divide by 3, and that's what they have in common here. You also know that they're both divisible by 1a because there's only 1a over here, so we can cancel that out. And we also know they're divisible, let's put that over there in a common pile. And then we also know that they both have an x. We could do x squared because this only has 1x. So there we go. So we know they're both divisible by 3ax, and that's what's going to go on the outside here. And then if we do some math, we figure out what cancels out. So take that out, and take that out, and you end up with just this first monomial becomes just 3a. And we do the same thing over here, which is 5, no more a's, and this x squared divided by x is just x. So there you go. So they had a 3ax in common, and then what remained was this. So that's one way of doing this problem here. Another thing you could have done, which I like, is like the ninja method. So instead of writing 9a squared x, we just write it out almost like prime factorization. So 9a squared x would just be 3 times x, times a times x. And then 15ax squared would just be 3 times 5 times a times x times x. I know it's a little crazy, but right away it's really easy to see what they have in common. They both have a 3, they both have an a, and they both have an x. And if you notice, what is left is what goes inside. So 3a is left over here, and 5x, and the plus sign is over here. So this method, although it takes some more work at the beginning, actually makes the whole thing easier. Your choice.